Alright guys, welcome back to Algebra 2 class today. That's what we're going to start with on my videos because I've been putting those off because this work is a lot harder than the other classes and I didn't want to do it. I'm just like you guys. I kind of feel bad for assigning you all this work now that I'm looking over it and everything. It's different when we're in class. I can see how long it takes us to do a problem, so then I know how many to assign to see how well you get it. But since you're not in class and I don't know how well you're going to get this, I may shorten this up a little bit. This is covering Rationalizing the Denominator. It's on page 202 and 203 in our Algebra 2 books, and it's all about removing the radical out of the bottom of a fraction and multiplying by the conjugate to do so on some of them. Now this is the work on page 203 and I have you assigned to do all of them, but I want you to stop after 12. That's going to be a lot of work, so just go ahead and stop after 12, no big deal. I also want to know or want to tell you that if you're watching these videos and trying to learn, whether you get it all or not, I'm going to give you some extra credit for that. So if you watch the video and you take all the notes that I write on the board and you turn that page in separately, not in a notebook, but separately with the assignment, I'm going to give you extra credit for each one of those on each video. So that I at least know that you're trying, you are watching the video, so you are spending the time in class. That doesn't mean you don't need to try on your work. There better be something on that paper. Don't give me a blank paper. But hopefully that will help offset some of this craziness going on. So we're going to start out on page 202 because they're a little bit easier. Rationalizing the denominator. We've already done that somewhat. Can't have a radical in the bottom of a radical and you're getting rid of it. On problem 2, this is a square root down here. So what I want to do is make sure that all of these things are squares. So I need to multiply by something that's going to make these squares. They're letters, so that's a little bit easier. Whatever I multiply on the bottom, I must multiply by on the top. But we don't care if there's a radical on the top. We just want the radical out of the bottom. So this is an a to the first power. I want to make it a squared, so I need to multiply it by another a because a times a makes a squared. Okay, this is a b, so I want to multiply it by a b to make it b squared. And this is a c3, so I want to multiply it by a c to make it a c4 so that it is divisible by 2 and is a perfect square. So that's what I need to multiply on the bottom, so I need to do so on the top as well. When I do that on the top, right now I'm going to have BC times ABC because those are not square roots. I can't take anything out yet. On the bottom, and I'm breaking this down in steps, I would, if it was me, I would surpass this step, but I want to break them down for you. I would do a times a, which gives me a squared. B times b gives me b squared. C3 and C1 gives me c to the 4th. Okay, now it's time to reduce. On the bottom here, the square root of a squared is an a. Square root of b squared is a b. Square root of c to the 4th is c squared. Remember, you're just dividing by that root on the outside. On the top, I have bc radical abc. I cannot do anything with radical abc. It does not have a perfect square. However, I can cancel out my b's because they divide into each other. A fraction bar is nothing more than a division bar. And then I have c1 here and c2 here. I can subtract those, but my c's got to stay in the bottom, remember, because this exponent is bigger. So this c is going to go away, and that's going to turn into a regular c. So my answer here would be 1. And I don't have to write the 1, but I am because there is something on the bottom. That would be the answer there, okay? That was like the second problem, so that's about as easy as it's going to get. And the rest of these are a little bit harder. So I apologize again for giving you the work. Remember to stop at 12 on this one. but do all 8 of this page. So you got that down. I'm going to move it out of the way so I have room for number 5 here. I'm trying to think of something that I could talk to you about when I'm erasing the board so it's not dead air, because we always usually tell some kind of stories, or the kids will ask me some oddball question in the middle of class that has nothing to do with anything to try to get me talking about it so that they can postpone my lesson and hopefully not do more work. However, I tell them that's fine. If they want me to talk, I'll talk, but that's less time I get to teach you, and you're still going to do the assignment. So it's a double-edged sword, but they still do it anyways. But right now I can't think of anything fun to talk about, so we'll move on. On number 5, we got the same scenario. It is a big radical instead of 2 separate radicals, like we had on the last problem, but that's okay. It means the same thing. But this is a cube. I picked this one because it's cube, not a square root, so we don't want these to be squares, we want them to be cubes. So what I need to do is find something that multiplies by this bottom that is going to make this a cube. That's a 2. The first number cube is 8. 2 times 2 times 2 is 8. So I want to make this an 8 so that I can pull it out. What do you multiply 2 by to get 8? It's 4. Alright, and then any of the letters need to be 3s or 6s or 9s. They need to be multiples of 3. So if that is an a to the first power, I need to multiply by a to the second power to make a 3. That's an x to the second power. I need to multiply by x to the first power to make a 3. Whatever I do down here, I must do at the top. Okay, now when I multiply this, I'm going to move it up here. I know it's weird, and I do this in class too. I apologize, my organizational skills are not very good. Alright, when I multiply those together, and I've already did this on my paper, but when I multiply those together, I'm going to have on the top 4a to the 4th bx, and on the bottom I'm going to have, don't forget these are 3's, and I separated them. You can still use the big one if you want. I'm going to have 8a3 x3. Okay, that's 2 times 4 makes 8. A to the first and a squared make a to the third, and x squared and x makes x to the third. Okay, now I need to simplify this. Alright, so at the top is a cube root. There is no perfect cube of 4, so 4 has to stay in there. However, that's an a to the 4th. That could be broken up to a3 times a1. So if I pulled that out, 3 goes into 3 one time, there has to be an a out here. That one's gone, and that a stays inside. B is not a multiple of 3, and neither is x, so they're staying inside. On the bottom, we want everything to come out of the radical. If anything's left in the radical, you got more work to do, because the whole point is to get rid of the radical. Cube root of 8 is 2. Cube root of a3 is a. Cube root of x3 is x. The only other thing we can do, you're pretty much done, but these a's divide out. So your answer is actually radical 4abx over 2x. You can't divide this inside. If this is out of the radical, it can't get divided to the stuff inside the radical, if that makes sense. Okay? Alright. One more on this section, and then we'll move to the other dreaded section. I tried to work on the glare in here today, but I can still see it. Doesn't matter what I do, it doesn't seem to go anywhere. So I'm going to go ahead and move problem 8 up so I can work the correct way, since it might be easier for you guys. Okay, so problem 8 is x minus 2 and x plus 2, and it is a square root. There's no number out here, so it's a square root. So on the bottom, I want to multiply by x plus 2, and on the top, I want to multiply by x plus 2. That way we can get rid of the radicals there. When you do that, you should FOIL them, because that's a binomial and that's a binomial. So on the top there, if we FOIL these like this, we should have, I think that's right. Yeah, okay. We should have x minus 2 times x plus 2, which is going to turn out to be a difference of squares because they're the same thing in the parentheses, 1 plus and 1 minus. So we're going to end up with an x squared, and then 2 times 2 is a 4, and it's going to be a subtraction. But that's under the radical. And the reason for that, if you went back and FOILed that, is that the two middle terms, because one's a minus and one's a plus, cancel out, so it's not a trinomial. All right. On the bottom, however, I'm going to write it like this. Okay, I'm not going to FOIL it. If I FOIL it, I don't know why that's flashing. Okay. If I FOIL it, I'm going to get this big perfect square trinomial that I don't really need because I'm not going to do anything else with it. If I square this thing, when I take the square root of it, it's just going to be this. So it's much easier to do that than to take the square root of a perfect square trinomial. So what I will do is leave this like that, and then the square root of this whole radical is just x plus 2. And that is your answer, okay? So even though I could have FOILed that and got x squared plus 4x plus 4, I would have had to undo all that to take the square root out of it, so it didn't make sense to do that to me. All right? All right, the next page is all about multiplying by the conjugate, which is what that difference of squares thing is here. Multiplying by the conjugate is multiplying by like its opposite. So if you had x plus 3, its conjugate would be x minus 3 when you multiplied. But it's to make that difference of squares and to make the things cancel out. All right, so that's what the second part of this lesson, which is continued on page 203, is. Again, only work to problem 12. The other ones are a doozy, and I spent about 20 minutes working 2 of them out on my own, and I didn't really want to put you through that. So just work out 1 through 12, and we're doing 3 of them here. So multiplying by the conjugate, I'm going to switch colors. My markers are running a little low. I guess I'm going to have to get some new ones. Means that you're going to do the opposite sign, but keep the other things the same. So when I multiply by a conjugate on this one, on the top, I'm going to multiply by radical A plus B. On the bottom, radical A plus radical B. Whatever's on the top, whatever you multiply by has to be the same on the top and the bottom so that you're not changing a fraction, because that's just 1. When I multiply on the top, I'm going to get C radical A plus C radical B. Because this is on the outside, I don't multiply it on what's inside. If they were both on the inside, I would multiply them, okay? On the bottom, remember, this is a difference of squares like this one. So I do not, when I FOIL these, I do not need to do the middle part, okay? I just need to do the F and the L of the FOIL. And you're in Algebra 2, so hopefully you remember that. But the O and the I is going to cancel out. So I just need to do A times A, which I will do this slowly, so that's going to give me radical A squared. This will always be a minus, and then B times B, which would be B squared. The only thing I can do is take those out of the square roots because they're perfect squares now. So that actually cancels, and this would just be a minus b, and that's gone, and then that would be your answer, this over a minus b. You don't leave those in the radical. That's the whole point, is to get rid of the radical. Okay? So some of these aren't as bad to me as those. For some reason I like working with the conjugates. But here's another one, and now we have a number on the outside which changes it just a little bit. But still, when I multiply by the conjugate, whatever I do on the top, I do on the bottom. Okay, this was a positive, so all I did was change the sign, and then I'm multiplying it exactly by itself. On the top here, 7 times radical 3 is going to give me 7 radical 3. And then that's a minus sign, so 7 times 2 is 14. And that radical 5 is going to come along, but that 14 is negative, okay? On the bottom, I'm going to get radical 3 times radical 3, which makes radical 9. I will reduce this like that one, but in a minute. And then on the outside, I'm going to get 2 times 2, which is 4. And then radical 5 times radical 5, which is 25, okay? Now, the square root of 9 is 3. The square root of 25 is 5. So that makes this 4 times 5, which is 20, and 3 minus 20. Okay, well, what's 3 minus 20? It's 17, correct? A negative 17 at that. So I would have 7 radical 3 minus 14 radical 5 over negative 17, I think. Or make the problem 17 or whatever. I'm just going to put the negative there for now. And there you have it. Alright, so 12 is going to be the hardest that you're going to have to deal with on this page. So I have it right here, and I'll do all the work down here. I'm going to move this out of the way so I can at least multiply by the conjugate. So on this one, remember, whatever we do at the top, we got to do at the bottom. That's a radical 5, and we need to do by a minus. And so this one's going to be radical 5 and a minus, and then 2 radical 3, 2 radical 3. Okay? Now, we got to multiply those together. At the top one here, I have a 2, and outside here is a 1, so there's going to be a 2. And then radical 5 times radical 5 makes radical 25. Yes, I will simplify that, but I'm just going to write it all out first. Okay? And then negative times a negative is going to make a positive. And 1 times 2 is going to be a 2. And radical 3 times radical 3 is going to be radical 9. I will simplify that because it's all going to be numbers. I'm not even on the right page when I'm looking on the book. I could have wrote this down totally incorrect, but hopefully I did not. I feel like I just didn't foil that. Oh, I didn't. Okay. Because these are not the same, they're not the same signs, and they're not the same, the top part is not a conjugate, just the bottom. It's happened to work out to where we've only had one thing on the top, but now we have a binomial and a binomial. So we have to FOIL that completely all the way out. I just did it like we did the bottom, and that is incorrect, okay? You have to FOIL that completely out. So my first would be 2 radical 5 times radical 5. That's going to give me 2 radical 25, and I'll reduce that in a minute. My outer, this is negative and that's positive, it's going to be negative. 2 times 2 is 4, and 3 times 5 is 15, so this will be radical 15. My inner, this is negative, that's positive, so this is going to be negative. Radical 3 times radical 5 is going to be a radical 15. And my last would be a negative times a negative, which is a positive. 2 times the 1 out here is 2, and radical 3 times radical 3 is radical 9. And then I'll simplify that, okay? So be careful. This was the first one that had a binomial on the top, and I was just rolling with what I was doing there, and I messed up. It happens, but this is the correct way to do it. On the bottom, because they are the same and they have opposite signs, we don't have to do the O and the I, which is why we just do radical 5 times radical 5, which is radical 25, and then 2 times 2, and radical 3 times radical 3. Okay, so now I have to simplify that, and that is a ugly handwriting and a mess. My apologies. We need to simplify that. All right, I guess I will move it over here and simplify. On the bottom, square root of 25 is 5. Okay, square root of 9 is 3, and 3 times 4 is 12. So that's 5 minus 12, which would be 7. Okay, a negative 7. You can put the negative there or outside or whatever. But that's what we have left on the bottom. Okay, on the top, I have 2 times radical 25. Radical 25, the square root of 25 is 5. So 2 times 5, that would be 10. Okay. These two middle terms right here are both radical 15. So I can go ahead and combine those together. Negative 4 minus 1 would be negative 5 radical 15. There is no perfect square in 15. And then this last one, the square root of 9, is 3. 3 times 2 is 6. Okay? Whoa. 10 plus 6 is 16. Okay? So if I write this neatly, which you should, I'm going to have 16 minus 5 radical 15 over 7. And I would prefer that the negative come out here, but that's what we're going to have. Okay? That is as hard as it gets today, and I think that is hard enough. Have a good rest of your day, and God bless you.